Hey guys, welcome back to another lesson. Today we're going to be talking about compositions of transformations. In other words, let's do like 2 or 3 transformations at once. Huh? Sounds like fun, doesn't it? Yeah, it does. Yes, shake your head. Yeah, it's fun. Trust me, it's going to be fun. We're going to go through 2 examples today, talk about some notations and some things we have to kind of be careful for. All right, here's our first example. Boom. Okay. And tell you what, I'll write down the coordinates off the side and the transformations that we're going to do for this guy. Okay? So first off, what are we doing? We're going to translate 5, 0, and then we're going to do a reflection across the x-axis. Okay? That's our goal for it. And what we start with is -3, 4 for B. G is -1, 3, T is -1, 1, and then S is -4, 2. Okay? So that's what those coordinates are. Now remember, we call this the pre-image, is what we start with. And what we end with, we call the image. Now we're going to have 2 images actually up here, and we have to be very careful on distinguishing between them. Okay, first step, translation. That's what we're going to do first. Now, 5, 0 indicates that I'm going to be moving to the right by 5, and 0 means I'm not going to move my points north or south, up or down. Okay, that's what the 0 implies. So every one of these points, let's go ahead and move to the right by 5. That's my first transformation. So let's see. 1, 2, 3, 4, 5. So here is G prime. 1 mark, right? We got to make sure you put the prime marks in there. Okay. Next up, oh, I think, did I put that? 1, 2, 3, 4, oh, nope, 5. Sorry, I was 1 space off. Okay, B is right here, so I'm going to do 5 spaces, so 1, 2, 3, 4, 5. So there would be B prime. Let's see, T, 1, 2, 3, 4, 5, so there's T prime. And then S would be 1, 2, 3, 4, and 5. So there is S prime. Okay, moving everything over to the right by 5. And I apologize, Claire. Oh, I don't like that. Sorry about that. There we go. Here we go, and yep, G's off, isn't it? G should be right there. I apologize. Let me just change that. There we go. Okay. Something still seems off, doesn't it? This is how you can tell it's live, see? There's 1 point that's off. I'm trying to think where. B's in the right spot. G's in the right spot. Is T in the right spot? 1, 2, 3, 4, 5. Yep. S, 1, 2, 3, 4, 5. No. Aha! That's where I made my mistake. S was in the wrong spot. There we go. Sorry about that. Small error, but hey, we fixed it. It's hard, like I said, when you're recording and you're looking at this off to the side, it can be a little tricky. Now, why the prime marks? Because before it was like, well, we need to know what we start with and what we end with. Here's the other reason. I'm doing another transformation. But when I do the reflection, I'm going to reflect this guy right there, okay? It's the new image that you just graphed. Now, going back to our reflection rules, they're equally distant to the line of reflection, which is right here. Okay, so my x-axis is my mirror in this case. So what I'm going to do is I'm going to count every point to that mirror, and then from the mirror, count the same number of spaces. Okay? So let's see, T is 1 space away, so then T double prime. I'm going to put 2 prime marks there, okay, to indicate that that's the second transformation that occurred. Okay? G is 3 spaces away, so then G double prime would be 3 spaces away. S is 2, so S double prime is 2. And then B is 4, so then B double prime would be 4 away as well. Graph our points. Just like that. There we go. And we have our final answer. This guy down here is what we're looking for. Okay? I still want to see. Now I know if this is our answer, why even graph this intermediate step? Okay, I want to see that. That's going to help you to figure out what your final image is going to be. All right, so don't change things. Don't just skip some steps. Do it properly. All right. Now this type of composition, we call it a glide reflection. Now, why is it called a glide reflection? I'm so glad you asked. You see how in this direction I'm moving to the right? So my vector, my translation vector, is moving to the right. Now, my reflection is across the x-axis. So you see how the reflection is parallel to the translation vector? Because of that, we call it a glide reflection. All right, just kind of like a special name for a certain type of composition. Okay? That's it. One final note, and then we'll do one more example. Notation. You could list it, your transformations like this, and then go ahead and perform them. Or you could write it a little bit differently, almost like a function notation in a way. You could write it like this. All right? Whatever you start with, so we start with a translation of 5, 0. Put like a little oval right there, okay? A little circle. And then next to it, put the next transformation that you did. So reflection of the x-axis. When you see this written with that little circle, you're going to read this from right to left. Not to confuse you anymore, all right? But if you see it written like this, you're going from right to left. Why this notation? I'm going to be honest with you. I don't really know, to be perfectly frank. Here's what I would say. And honestly, I should probably research this myself. But here's the reason why I think it's written from right to left. If you go back to your Algebra 1 days, if you remember compositions of functions, looks very similar to this notation, you would go in this direction, right? You would go from right to left, inside out. I could write this as f of g with that little circle there. And that also indicates from right to left. My personal explanation as to why it's written like this is to align up with your Algebra 1 days, okay? Or just algebra notation in general. That's my reason for it. Questions? Thoughts? Concerns? Dilemmas? Not too bad, right? Okay. Let's go ahead and do one more example. And we're going to include a rotation with this one. Something a little bit different. Okay. Let me just shut this off. Erase all of this. There we go. And let me write down our pre-image coordinates. So let's see. T is going to be at 2, -1. U is at 5, -2. And then V is at 3, -4. We're going to translate -1, 5. And then afterwards, we're going to rotate the image 180 degrees. About the origin, which would be counterclockwise. Okay, if they don't mention it, we always assume it to be counterclockwise. Okay? So go ahead on your graph paper. I want you to draw that as well. I'm going to do the same thing. And not that it's a race, but let's see who can graph it first. Boom. Done. Did you beat me? So here's my pre-image, is what I'm going to start with. According to the instructions, I'm going to translate it first, -1,5. Now, what does -1,5 mean in some English terms? Well, it implies that I'm going to move all my coordinates to the left by 1. The positive 5 means I'm going to move every coordinate north or up by 5. Okay, so left 1, and then we're going to go up 5. Okay, that's what this first part is indicating to me, and that's what we're going to do. Now, typically I would draw it on the board. I'm actually going to put that right here, and I don't want to blind myself, so I'm going to take that down and then draw it. I encourage you to do the same thing. Go ahead and do the following translation. So it's to the left 1 and up 1, 2, 3, 4, and 5. Making sure you're putting a prime mark. Not that this is a race, but I'm almost done. There we go. Okay, so there's my translation. Every point went over to the left 1 and then up by 5. Okay? What's next? Well, we have to rotate it 180 degrees. Here's where the symbols are very important, just like the previous example. I want to rotate this image 180 degrees, not this guy, what we started with. The ones that have the prime marks on it. Okay? Let's go ahead and do that. If you recall from the previous lesson, when we rotate an image 180 degrees, that's when we're actually going to turn the paper twice. Each turns 90 degrees. Going in counterclockwise in this direction. So once again, we have 90. That's what it looks like. And then rotate it one more time. We have 180 degrees. Now from this, I'm looking at that graph, remember? Okay, that's what I'm focusing on. Now we're going to copy and paste. So over here, I'm going to write down the coordinates for each one of these guys. Okay? So for T double prime, it's going to be -1, 4. U double prime, 1, 2, 3, 4. Then we go down 1, 2, and 3. And then finally the coordinates for V would be -2, -1. Okay. Waiting, so far so good. Oh, let me just, there we go. So you guys can see it a little bit better. Sorry about that. All right, so we kind of like did that copy and paste, and we know what this is going to look like. Now what you're going to do is you're going to put it back to its original position. So it looks like this. Okay, let me get rid of that circle. There we go. Okay, so this is what it looks like now. You're going to take these coordinates that you copied, and you're going to paste them back on the grid. Let's go ahead and do that. So -1, -4, so here's T double prime, which if you remember, that's what it did locate to, right? That's where we stopped, started, whichever way you want to say it. U double prime, 1, 2, 3, 4, 1, 2, 3. So here's that location, and then -2, -1 would be the double prime there. Connect your dots. Cool. And there we go. So this guy is my final answer, noticing that every one of these has 2 prime marks, indicating that's the second transformation that has occurred for this problem. Okay. If I want to write this using that notation from before, remember, whatever you did first, you would put right here, put your small circle, and then what you did, what you did first was not a rotation, it was a translation. I apologize. And then what you did last or next goes afterwards. So then rotation of 180 degrees. So once again, you go in the opposite direction if you see your instructions like this. Okay? If you had another transformation, you would just add another circle there and put whatever the next one is. Okay? That's it. All right? It's just reviewing everything you've done with transformations up to this point. I'll shut this off. There we go. and one little package. Okay. We talked about a glide reflection, which is just where the translation vector is parallel to the reflection that you're going to do, which could be this way or it could be this way, right? Either way, as long as it's parallel, we could do y equals x depending on the direction of the translation vector. And then we just did one normal composition. Okay. Can we do more than just two? Yes. Can we do 3, 4? Absolutely. The picture could be a little convoluted, which is why you want to label, okay, properly. That way you know which image you're working with. All right? Hope you guys are doing well. And until next time, I will see you all in the next lesson video. Take care.